Hello there, my name is Maher Haddad. Today I'm going to show you how to configure BGP for advanced topic for CCNP level. So let's go to the website. Let's read the lab scenario. You work as network engineer in a company and you have a network under BGP Autonomous System 2. Your company is connected to ISP using two routers. All IP addresses are connected. So this is our topology. We have ISP here. And this is our network, router 3, 4, 5. Everyone has loopback, which belongs to the number of the router. And then the router 3 and router 4 are connected to the ISP via serial interface, serial links, and then here is fast Ethernet interface. So our task: configure EIGRP 1 in your internal network without advertising the network connected to the ISP. So over here, and we don't have to advertise these two links, and ensure that you have full connectivity between router 3, 4, 5. Do not advertise loopback 1, loopback 2, and loopback 3 should be here of router 5 into EIGRP. So this 3 loopback 1, 2, 3, this IP address over here, we should not advertise them into EIGRP. Alright, so let's go to the router 3, router EIGRP 1, no auto summary, and network 192.168.35.0, then 34.0, and the loopback router 4, and loopback router 5, three 5.0, 4 5.0, and loopback 0, and the other loopbacks we should not advertise them. Alright, so let's check if we have neighborship. So router 5 form neighborship with router 4 and router 3, so it's okay. Router 4 with router 5 and router 3, and now router 3 with router 5 and router 4. Okay, so if we ping loopback of router 4, of router 5, so we are okay. So no need to do the others, to do ping on the other loopback, everything is okay. So task 1 is done. Now task 2, configure BGP in your internal networks in this area. So all routers will have neighborship to each other on the loopback interfaces. Okay. So on router 3, of course, no auto summary, and neighbor with loopback. And I have to put also update source loopback 0. And neighbor I do the same router 4. Okay, router 5. Okay, let's go to router 3 now and check if we form neighborship. So router 3 formed neighborship with router 4, but not yet with router 5. Still active. Okay, and prefix is 0 now. You can see router 5 is up with router 3. So also router 4, show IP BGP summary. Also is okay. Router 5 also is okay. Okay, we go to okay, we configured this one. Now number 3, configure BGP neighborship between ISP and connected router. So they didn't say on the loopback, so I will do it on the serial interface. So ISP, I go to the ISP, router BGP 1 here, no auto summary, neighbor 192. That's 3. Remote autonomous system 3. And then to router 4. We have to do it on every router, of course. Router BGP 3. And then on router 4. Remote autonomous system 1. So we can see that router 3 has formed neighborship with router 1. Let's check if router 4 also. Router 4 not yet. But you have to know that BGP is very slow routing protocol, because it's a routing protocol for the internet, and yeah, we have to wait a little bit. Okay, now it's up. Okay, so now we can see that there's neighbors between router 3 and ISP and router 4 and ISP. Alright, now advertise all loopbacks into BGP. Ensure that every router can reach the loopback of any router. If not, then solve the problem. Alright, so we have loopback here, ISP 1.1, 3, and here 4, and then we have a router 5, all these loopbacks. So as we are on ISP, let's go to router BGP 1 and then network. Mask 255.255.255.0. Then router 3 network. Mask 255.255.255.0. Router 4. Router 5. .0.1.0. 10.0.1.0 mask 2.0 3.0. to be sure that I have created the loopback, let me check. Yes, they are here. Alright, so now we have advertised all loopback. We have to be sure that we can reach any loopback from any router. So let's try from okay, let's first check if on ISP we have the advertised loopback are shown on the ISP. So yes, they are shown over here. So if we do show IP route, of course we can see them into our routing table. can see BGP, B is BGP. But first of all, this is ISP, and then we can check router 5, show IP BGP. So here there is a problem that you can see it, the router 5 cannot find 1.1.1.1. There is missing of this greater sign, which is best, this one. And the reason why is because the next hop is for this network is 192.168.13.1. 13.1 is this interface over here. So router 5 doesn't know about this interface. So what we have to do, we have to go to router 3 and router 4 and say that they are the next hop self. That's first thing to do. So let's go to router 3, and here I say neighbor 5.5.5.5 and next hop self. I'll copy this one. I'll do the same on router 4. Okay, now if I go back to router 5, so IP BGP, then now you can see it's shown this greater sign. Now if I try to ping 1.1.1.1, which is ISP, I'm not able to. And now it's not because of, the next next hop self. It's because router 5 is going to router 3, but the router 5 doesn't know this or this links on his BGP. So what we need to do, we have to advertise these two links into BGP. So I can do it on router 3 and on router. What I will do, I will advertise all the links, so everything will be working. Because also later ISP will not be able to reach router 5 because he doesn't know about these two links. But let's try first on router 5. I will go to ISP, for example, here, and I will say router BGP1 and network 192.168.13.0 mask 255.255.255.0 and then 14.0. Okay, now if I go back to router 5, I do show IP BGP. So 13.0 is shown. So now let's try to ping 1.1.1.1. It's not able. I think it should be advertised also from router 3 and router 4. So I will advertise all of this on router 3 and router 4. Here I will say network 192.168.13.0 mask 555.555.0 and on router 4 I will say network 192.168.14.0 mask 255.255.255.0. I go back to router 5 now. Still not able. Alright, I will advertise this link, this and this link as well. Network 192.168.35.0 34.0 and then router 4 the 34.0 up. Then on router 5 I will advertise also router BGP 3. Okay, so let's try now. Now it's working from router 5 to ISP. Let's try the way back from ISP to router 5. .1.5 for example. It's okay. 2.5, 3.5. Alright. So what you have to do is you have only to advertise these links into BGP, then it will be working. Okay, and of course you have to not forget to do on router 3 and router 4 for the neighbor 5.5.5.5 to do next hop self. Okay, we go to this to the number 5. Make the change needed so that the ISP router, this router, can reach the network 10.0.1 and 10.0.2 via R4. So it has to go from here to reach 10.0.1 and 10.0.2, and then we'll go to and to reach 10.0.3 it has to go to router 3. So in brief, if ISP wants to reach, let's suppose that this is a web server over here or whatever, so in order to reach 10.0.1 and 10.0.2 it should take router 4, and if we want to reach 10.0.3 it should take router 3. Okay, and they said hint is metric, so we have to use the attribute metric. Now this will have to be done on router 3 and router 4. So I go to router 3. Router 3, and here I have to say access list 1 permit 10.0.1.0. So I'm classifying the IP address now, and then I will create an access list 2 for this IP address. Then over here I will have to create a route map med, I'll call it permit 10, and I will say match IP address the access list 1, and set the metric. We have to put the metric for now we are matching one which is 10.0.1 and 10.0.2. so we have to put the metric high because we don't want this to go through router 3. So we have to put metric 100. Then I have to say exit. Then I will create another sequence for route map 20, and then I will say match IP address now 2, which is this IP address at this network 10.0.3, and here I have to say set metric 50. So we'll make it lower so it takes this way, and then we have to create finally route map met the permit sequence number 13, and that's will keep it empty. This means that it match anything. So if we just check what we have configured, show route map, so you can see here that sequence 10 match access list 1 and give metric 100. Sequence 20 and match access list 2 and give metric 50, and then sequence 30 it match anything. So this is for these links, for example, which are here. Alright, now we have to apply the route map. So I have to go to router BGP 3 and neighbor 192.168.13.1, which is ISP, and here I have to say route map, and we name the route map med, and it should be the way out. Okay, so this is on router 3. So if I do show IP BGP now, yeah, we don't see anything on this router, of course. But if I go to ISP, you can see that we have, of course, this is something we have to know about BGP, that we have always to clear the process to take effect. So as you can see now, everything is going via router 4, and the reason why is because router 4, the metric is 0. So we have to do the same job what we did on router 4 as well. So I have to go to router 4 now, and here I have to create again access list 1 permit 10.0.1.0 access list 1 permit 2.0, and then access list 2 3.0. and now I create a route map. I will name it also MAD. You can name it anything you want, but I just yeah, because we're doing metric now, attribute, and here I have to say match IP address 1, and here I have to set the metric lower, because the lower the better, because we need these two IP addresses to go from router 4. So set metric of 50, then exit, then I create sequence number 20, match IP address 2, and then set metric to 100. So this means to reach this network you should yeah, it gives 100, while the router 2 gives 50, so that it would choose router 2. And then finally 30, which match everything. And now I have to go to router BGP 3, and I have to say neighbor 92.168.14.1 route map med, and the way out clear IP BGP star. Okay, so now let's have a look on ISP. Okay, if you can see here what's happening, I think it's not so I'm checking here. It's going to router 3, going to router 3, going to router, then there's show IP BGP summary, IP BGP. Okay, now it's better. Okay, so what we can see now is 10.0.1 is going via router 4, and that's what is needed, and 10.0.2 is going via router 4 because the metric is 50, of course. Then 10.0.3 is going via router 3. So this is the our object. Here they said make the change needed so the ISP can reach the network 10.0.1 and 10.0.2 router 4, which is here 10.0.1, 10.0.2 router 4, which is correct, and then 10.0.3 via router 3, 10.0.3, this one here, you can see the best, via router 3. So we have accomplished the mission. To be sure, you can just do trace route. For example, trace 10.0.1.5, and this is going to router 4, going down router 4. If you do 10.0.2.5, also is going via router 4. Okay, that's good. Then if we do .3.5, then it's going to router 3. Alright, excellent. Now, make the change needed so that R5 can reach the ISP router by taking the path via router 4. So this router 5, if you want to reach this network here on ISP, it should take the path on router 4. So let's check now what path is taking at the moment. So if I do show IP BGP, at the moment we can see here that it's taking the router 3, the path of router 3. So what we have to do, we have to make it to go for router 4, and they give us a hint is you have to use local preference attribute. So again, I go to router 3 and router 4, which is where we have to do the change. I create an access list. Let me check what was the number I used for access list. 1, 2, I'll create 3. Access list 3 permit 1.1.1.0.0.0.255. Now, local preference, the higher is better. The metric, the lower is better. So you have to remember those. Now, I create access list. I have to create a route map. I will name it local preference. Local preference permit 10. Match IP address 1, and set local preference. So we said the higher is better, so we have to make it lower. So I will put it 50, for example. Local preference 50, and then I will go to router BGP 3 neighbor. So now you will see that I was doing the neighbor with route ISP and not with router 4 or 5, but I will do it the way in. So neighbor 192.168.13.1 route map local preference the way in. Clear IP BGP start. So now I have to go to router 4 and make local preference higher. I have to create first do show access list. So 1, 2, I create access list 3 permit 1.1.1.0 0.0.0.255. Now I create route map local preference also permit 10 match IP address 3. Did I put my IP address 3 or match IP address 1? I put it here. It's wrong. So let me correct for the router 3. Router BGP route map local preference route map local preference, and it was permit 10. Now match IP address 1, and I have to put match IP address 3. Let's check now the route map. We have to check show route map local preference. This is what I want to work on. So route map local preference sequence 10 match IP address. Okay, that's correct, 3. But then we have to do route map local preference permit 20, and that's it. So if I do now show route map local preference, yeah, it's much better. So now we are matching access list 3 and we are setting local preference to 50. Then we create sequence number 20 which match anything. So let me go back here. I have to do clear IP BGP star, and let me go back to router 4. So router 4, I was saying match IP address 3, and now set metric at set local preference to 200. Exit. Then route map local preference permit 20, and then that's it. So if I do show route map local preference to show route map local preference, so we are matching access list 3 and we are setting local preference to 200. Then we are matching anything. That's good. So now I have to go to router BGP 3 and I say neighbor 192.168.14.1, and then route map local preference, and now the way should be in. Now clear IP BGP star. So yeah, it's all about logic. So now let's go to router 5, show IP BGP. Let's wait a little bit. Show IP BGP summary. Okay, should be now up. Show IP BGP. So now, as you can see here, that router 5 has chosen to go to router 4 in order to reach the ISP network, because local preference is set to 200. Okay, so this is what we need to see. Now someone would ask, what if the network over here will go down? What would happen? So let's first do trace route to 1.1.1.1 to be sure. So as you can see, it's going to router 4. Okay, now if let's say the link goes down over here. So for example, if I do interface fast Ethernet 0/1, which is this here interface, fast Ethernet interface here, and make shut. So what would happen? What would happen in this case? Am I still able to ping 1.1.1.1? So let's try. And yes, we are able to ping it. If I do trace route now, 1.1.1.1, so what you can see here is going from this side to router 3, and then going down to router 4, and then going back to ISP. And the reason why, if I go to router 3 and I do show IP BGP, is because also local preference is shown as 200. Okay, now on if you do show IP BGP, you can see that it's still pointing to 4, but as you can see on trace route, it goes to router 3. So don't worry about that. So let me bring up the interface now. Pick it back up, and now do trace route to ensure that everything is working as requested by lab scenario. We already did it. So this is all about BGP for CCNP level. I hope you enjoyed this video.